Welcome back. Today we will discuss on the cantilever steel beam analysis and design. It's the first video tutorial explaining a problem, and let's open the start application. For clicking the start, we'll get an interface like this. So as we discussed in the last video, open a new project, and as we are going to analyze a beam which is having the behavior planar behavior. That is, all the deflections, bending moment, shear force, all will happen in a single plane. We are actually ignoring the lateral movement provided we are giving the lateral restraints. So we can directly give the plane element, not space element. We can give it the file name, steel cantilever. And we can select the location to which the file has to be saved. So to this, both they can change your own. And you can see here the definition of plane structure is bound by an XY global coordinate system with loads in the same plane. So if we have X and Y options, SY coordinates, you can apply or draw the beam only in SY coordinate, and the application of load should be in the SY coordinate. The Z component is not possible to provide for this problem. So meter is a unit and the kilonewton. So these things can be set even in the configuration as we discussed in the previous video. So next, so we are directly going to start with the beam. We don't have a plate, we don't have a solid. And so the begin building per model by creating new joints and beams by using the construction grid, drawing tools and spreadsheets. So you can directly start drawing the beam by taking this option. This is finished. Yeah. So this is the interface, and this is in a slightly inclined mode. So these are the different viewing options. You can click on the front view option. So by default, the add beam option is on the left side. You have first node cursor, second beam cursor. The beam cursor is active as we have given add beam option in the previous step. On the right side, we have the snap nodal beam option. This displays that table. We have the node source. So you can see the coordinates at the left bottom location. That is, x is in the horizontal, y is in the vertical, and z is the perpendicular direction. So as you know, as this is a planar structure, this component is always 0. So you can directly give the node value here like 0, 0, 0 as the origin, and all the z components should be 0 for this case, being a planar structure. And by default, all the nodes or the grids are separated by 1 meter in horizontal as well as the vertical directions. So here the options are there to create a new grid by giving some names. You can give any name here, and you can even change the plane also. Here now it is in the XY direction. When you click on XY, then you can work on the XY plane. So to show that, let me directly go to the edit option. I'm just working on this grid. So editing XY is the current plane. So you can change to XZ. You can change to YZ plane, and also the angle also you can change with respect to the XX. We give some value, and the angle will be changed. To do that, you have to go for the initially it was 0. Initially, this is stage, and apply some angle to that. The angle of plane gets changed. Let us make it a zero itself, and the grid origin can be also changed. Like 0, 0, 0 is the starting grid. The spacing also can be changed here. Uh, in this problem or this dialog box, by default, all the 10 nodes is x you have 0 to 10, and all are spaced 1 meter, and my direction is also by 1 meter. If you want, say your beam length is 3.5 meter, so you can't directly draw the nodes by using this grid. In that case, you can change this one to say 0.5 meter. So number will change. There is only 5 meter will be available. We can relate that. If you click on that, the number of divisions got changed. Only one length will be 0.5 meter. So we will make it back to normal as previous. That's the initial one, and we are going to start. And you can close this tab. If you for drawing the beam, you can click on this icon. This is actually called step node or beam option, and you can give the values here. So I'm going to analyze a beam of length 5 meter. Giving a 0. So default, my first node will be on the 0, 0, 0, and I'm giving. As a second node, I'm giving it as x direction is 0, so it is 5 meter, it's the length direction, y is 0. So we have the two nodes. You can see here the two nodes, uh, 0 and 5, and you can directly join these two nodes on the node 1 and node 2. And after that, we can go to the geometry tab, which shows the beam of 5 meter length. Next, we have the options to give the support condition for the beam, to give the member sizing, and also to analyze the beam. So to give the supports, you have to click on General on the left tab, then click on the support option, and then click Create. Here you can see different support options like foundation, settlements. If it is there, you can give uh, as required. The footing, the elastic mat, plastic mat, which requires some spring coefficients can be given in the foundation support. There are options for giving the inclined supports even by the spring stiffness. Then the supports which have got tension or compression only spring options, multilinear spring options, and foundation inclined tension or spring compression options. Tension or compression only spring options, fixed option, which is very common and known to you, fixed pinned, fixed but enforced. These are like the fixed supports with some releases which are possible. Enforced means fully fixed and fixed, but we can define the spring stiffness for other joints. There are pinned option, that is the moments are released. Only tick means it is restrained. All the horizontal and vertical movements are restrained, and this is actually the fixed. And you can see that fixed and enforced are more or less same. Even the fixed but and enforced but, in the fixed but you can give the spring coefficients as the support reaction. Enforced but is only directly the values, checking or unchecking the corresponding deflection or moments. These are about the support table. You can go for the cantilever beam so fixed. Then click on add. Save it. Save. So the S2 will be our new support, which is the fixed support. And now we have to assign the support to the beam. So for assigning, we have different options like assign to selected nodes options are there. This will be active if you click on the nodes. Then assign to view option is there. Use cursor to assign option is there. Assign to edit list options. You can use cursor to assign option, and yeah, this is very important. Now I am not able to select this one. The reason to that is we are giving the support to the node. So by default or at this time, my beam cursor is active. I will change to the nodes cursor. Now this is actually in active mode. So you can see on clicking on support, we have use cursor as an option. You can, if you select it, when you can see here while moving our sorry, this was changed by clicking on the node option. You get the node selection and assign to select nodes. Yeah, only here we have the fixed support. Then we can click on the assign, give S option. So by this way you have given the fixed support. Another way is you can assign to edit list. That is, you know that the node 1 is this and node 2 is this. If you give node 1 here and assign, that is coming here. If you are giving 2 and giving assign, it will come to second node. And if you are given one space to, both the nodes will receive the fixed support. So I'm giving directly only one. So assign to edit list we have checked. With cursor to assign we have checked. Assign to view option, if you click on that, then all the nodes available in the screen will get the support. And another option is we can edit undo. First option, you can select the nodes first, and then by default this will be active. Assign to selected nodes. Click on that assign. The support got removed. Just creating it again. Fixed add. I'm selecting the node, clicking on support. Now both the node selection as well as support 2 is active. Assign to selected nodes. Click on assign. Now it got. So the thing is that the node should be selected before and the corresponding support should be active. Then you can click on assign to selected nodes. So these are the options to give the supports to the desired nodes. Next comes the property. So same in the general tab, we have used the support option to give the support to any nodes. Then you have the property, then you have the specification, loads and definition, and the material. Click on the property, you have a new dialog box coming, and section beta angle are the faculty section. We are going to give the steel as a member, so you can check the different options available. Edit option, delete options are there. Values, you can directly give the uh, new properties here. Then this session database is used for providing the steel members, and define option is given for making the rectangular sections, sorry, RCC sections of different rectangular circular shapes. In this video, we will focus on the steel table. You can even give the materials. Aluminum, concrete, steel are available by default, and we can even provide the thickness. In the case of plate, in our case, it's not required. And user tables can create like adding new members or new properties. Okay, we will check the session database first for our case, steel bead. On clicking that, uh, on the left side, you can see the top. You can see steel, the different codes based on the country. American code, American steel jobs, Australian and Indian have just selected here. This was active as I have configured the Indian code for steel design. You can check the previous video for that. And then the call form steel, specifically it was American call form because I haven't given the Indian standard scores for the call form steel. And then timber aluminum, it will come as automatic. We haven't configured that. Coming to the steel, we have the different. So I just selected American, it got changed, and we have the Indian here, and we have a different shape like IS shape, A shape, M shape, W, T, channel, angle, tube, pipe, etc. And you can click on this view table so that you can see in an enlarged way. So you can check with the uh, corresponding Indian standard steel table to know about these angles. Sorry, these sections and their properties are directly available in this table. The serial number, names of designations of various steel profiles. The start name, more or less same, ISLB 75, yeah, same. So then area, AX, D, BF, TF, thickness of plants, breadth of plants, thickness of web, the moment of inertias, like the Z value, section modulus, radius of curvature, rivet diameter, all are available in these tables. Just closing this one, and here you can select the material also, or steel, stainless steel, aluminum, concrete. You can check what we are working with the section profile steel, so you can select the steel, and then single section from table, T section, double profile, combo section, top cover plate, bottom cover plate. All those things can be explored. So now I am focusing on ISMB. We are still a larger section to give enough information. ISMB 600. I am clicking on add so that the steel profile is available in the main dialog box. Clicking on close. Then I have to assign this property to my beam. So as we seen for the previous support condition, it's not that supports are given for nodes and the section properties are given for the beam. So here the node beam cursor should be active. It is there, and the same assignment methods. You can directly select the beam, assign to selected beam, assign. Yeah, it is done. So R1 is the material. You have steel ISMB 600. So you edit. Other option is here. Click here is cursor to assign. I'm just clicking on the beam and then assign. I'm not doing that. It can be done like that. And next is assign to edit list. So the beam one only is active here. Assign will give you directly that value. If you click on 2, let's see that because it is not available, it's directly going to 1. Yes, only we have only one beam. Assign to view is also fine for this because only one beam is there. Assign. So we have given the support condition and the properties. Next, to introduce, we have the specification tab, and this is to give the specifications for the individual profiles. You can click on edit option, uh, delete options. Once you create a specification, nodes, this has to be explored, and the beams. This is very important for our case. Like we can define the member as only compression member, only tension member. We can give some fireproofing to the member. We can define as truss. We can give imperfection. So all the uh, things which we need to focus on the beams, or we have to change for the beams, can be done on the member specification. Say this is actually a beam, right? Suppose I am going to make this as truss element. Not this is truss element. When we have to design for truss element, all the beams should be selected and should give the only truss option, so that all the members should take either compression or tension. If you didn't switch it on for truss configuration, then it will take bending also, which will be giving you error results. Then cable analysis. Suppose you don't have any bending strength, only the axial strength is there. You can give the cable. Reduction factors you can give as required, offset, release, compression, tension. All the things are available. Just closing that. The nodes also saying to that we have different options of giving the node information, the height, all things can be changed upon requirement. So after saving this, now we have the loads and definition. We have to give the load for analyzing the beam, and we have the material option which we have seen before. Steel, stainless steel, aluminum, concrete are by default. And you can even create also a new material here. You have to analyze for a new material. So those options are there. And coming to the loads and definition, click on that. We have when you click on the first plus icon, you have so you can see various definitions like vehicle definitions, time history definitions for earthquake analysis. The bin definitions, snow definition, reference load, seismic definitions, pushover, direct analysis definitions. So these are for the advanced analysis. Then click on the new case, sorry, load cases details, and you can click add. Yeah. So here I'm going to give only the dead load for analyzing my beam, and I'm clicking say on the dead load. I'm giving load case 1 here, dead load. Not add, and I'm closing that. And here upon clicking on the dead load, add, here you can give the different loads value. Here I'm going to analyze only for a free and point load and for the self weight of the beam. So directly I'm giving the self weight. When you explore for different loads, you have the self weight option, a nodal load which has to be applied on only on the nodes, a member load along the length like UDL, UBL, a physical member load, uniform force, moment, area load, floor load, plate load, surface loads, temperature, seismic, time history. All the loads can be given under this tab. I'm focusing on self weight. -1, I'm giving directly the value. So y direction is actually downwards. Should be that self weight, and -1 add. And I'm also giving a nodal load. Nodal load should be in direction of y, should be minus. I'm giving say 5 kilonewton, add, and I click on add. It already came here, and I'm clicking on close. So I have defined a load, no load case dead load, and I have given self weight and the nodal load. You can see a question mark here, that is these loads are defined but it's not assigned. To assign that, you can click on the self weight and you can give assign to view because the entire beam has to have the self weight assigned. So now this got changed. So it means this load is assigned to the beam. Now remaining is this one. Click on that and you can also give directly assign to view as we have only one beam. For a change I'm giving, use cursor to assign option. And click on this and I'm just assigning just a minute. Have yeah, I'm taking again the loads and definition, load case details, dead load, and clicking on the load, use cursor to assign, clicking on this, assign, double click on this one, you can even change the loads also. Okay, it's not some error is showing. I'm going directly assign to view option, assign. So this is actually a wrong selection. This is good to explain. So as I given the assign to view option, the load nodal load is given to both the nodal points, which is not our requirement. So edit, undo. So I have to, yeah, this was the reason for the previous error. That is, by using the cursor, it was my beam cursor was active. But for as this being a nodal load, my nodes cursor should be active for giving the load. That's why it's showing assigning and got some error. Now I'm clicking on the load, I'm clicking on the nodes cursor, then I'm clicking selecting this node and assign. This should work. Still some error, we will go with another mode. Assign the selected nodes, then give it the assign. So good work. So you can see that the load is applied at the free end. Now it's time for analysis because the cantilever beam is stable. We have given a low. Everything is fine, and directly to analyze, you can give for analysis and analysis option. Save. So here, some error showing. Yeah, so there is some two errors are showing. We can have clear that. The reason to that is we have to give the analysis or print option, and then you have to define the type of analysis, like perform imperfect analysis, buckling analysis, perform pushover, change, perform direct analysis. But we have to define the type of analysis, and we can click directly perform the analysis. No print, then click on add, so that it will be coming on the right dialog box. Then close. Then you click on the analyze and run analysis. Now we got now the start file run, and we got the result. So just reminding, the previous error was due to we haven't defined the type of analysis which has to be performed based on these loads. Right. When I'm just again taking that, we have different options like the perform analysis, P-delta analysis, cable analysis. All those things are there, which we can do based on our requirement. And we can for normal static analysis directly give you the perform analysis, so that this will come should be in the right dialog box. Then only the problem will work out. So for analyzing, I have get the analysis option done. So from here option also you have the output file, go to post processing mode and the strain modeling mode. You can click on the output file, done. Which this is actually the output file, which shows the different start commands we have given. So we have initially selected the plane, so start plane. We have given the directory to save this start file. Then start job information, date, input with join coordinates we have defined initially, right? The beam nodes. Then we asked to make the member, we defined the material properties. So all the things were given, self weight were given, join node were given, and we have given the perform analysis at the last stage. And this shows the number of joins in this problem. Two joins are there, one member is there. All those things are shown here. You can directly print this one. You can find any commands. All those options are available for printing and for editing. All those things are available. Just to tell you that there is a start editor which is in the second line. Yeah, here start editor. So this is actually start plane, start all those things which we have given as the commands are shown here. Say you have to analyze later the beam as a space structure. You can directly change uh, this to be space. So whatever you are changing in the interface, this user interface will come to this uh, commands, this coding, or you can directly change the coding also. Okay, right. If you want to change the analysis at last to make a period analysis, without clicking on those icons, you can directly type here period analysis and then finish and run means that will be performed. Yeah. So we are now in the design mode. Let's see the values first. So you have the modeling option, building panel, piping, bridge deck. So I will again run the analysis. Stay in modeling mode, which is this is the mode. Post processing means the result deflections all can be seen here. Output file, which I have just shown. You can go to the post processing mode done. We have given only the single load, dead load. Uh, then click on OK. This is actually the deflection. We can make it in the right, the front view, and you can click even on this rendered view to see the section we have given. Yeah, This is the section I section we have given as the steel member, and yeah, this shows the displacement. Yeah, so the displacements are shown here. That is for this dead load we have given, there is no x direction displacement. Is that is not there because we have analyzed for plane structure, and y value at the free end it is 1.696 is the ultimate or the maximum deflection at the free end. It can be checked manually also. So these are the deflection cap, and on clicking the post processing and then this one, this is actually the axial force which is not there for this case. Fy will give you the shear force. So the shear force is actually a combination of the UDL load like self weight as well as the free and vertical load. Then Fz value, you can untick this one, axial force of Fy of only Fz. Fz is not there, which is actually the about the Z direction. Then Mx of My. So this is actually the moment. This Mx, I'll just this ms is actually the moment about the z direction. It is actually sorry, x is the horizontal direction, and mx it means it is about the x. There is a torsion. There is no torsion. Uh, then my is also the lateral movement about the direction. It is also zero. Mz will be there, which is actually the bending moment. This is the bending moment thing, and this is the beam stresses. And so you can even click on different options are there to view the values. Even if you click on post processing, you could double click. You have to go to the modeling mode and click double click on this. Will get the geometry of the beam, proper geometry including the section sizes, all those things, the basic properties of the beam, the loading which we have given, dead load, the bending moment values, the deflection values are all shown here. So you can put 5 meter, then deflection in the y direction, yeah, 1.6 times. So you can change the different tabs and you can get the different values. Again, we can print the results also. So this all about the analyzing a steel beam, and for design purposes we have. And for design purposes, you can click on the uh, design option here and click on the steel option. On the right side, you have the new option define parameter options are there. Uh, Here you can give different values, and commands options are there. So what should be taken from the code, and then select parameters are there. So first you have to click on select parameters, then make all to the available parameters, then different parameters including the type of bracing, beam parameter, deflection, beam maximum allowable depth, pressure, torsion, restraint, all those things are there. Let's take only the ultimate tensile strength as well as the yield strength of steel for this design. Let us ignore all the other values for this corresponding topic. And okay, define parameters. So you have selected only the two parameters, ultimate stress as well as the yield stress. So you can give the value here. You can directly give this value itself. If you have a different grade of steel, you can change accordingly. Okay, the ultimate stress I'm giving as 40 for like 13,688 and Kilonewton per meter square, and the yield strength is also given. I'm clicking on both add. So then I can click even on assign also directly. So I don't want actually this. If YLD also I can assign because we have only one steel beam directly connected. Then click on close and this delete FSCs. So we have given the values and then command we have to check the code that is required. Add, check the adequacy of the members based on the specification of the said code. Yeah, it's a group member takeoff, self optimized takeoff. So all those things are coming here. And just deleting this command. Yes. Deleting this command. Delete commands. Or define parameters. If u is coming, if while the has, then click on this assign to selected modify. This is actually already there, so delete the command. Yeah. So code is I'm deleting the codes so that everything will. So I'll just redo that. Okay. Then use cursor to assign. This other way of doing assigning that. And then the commands can check for the code. Assigns. Check code is given. Then member takeoff can be given. So they can check for total quantity of steel. So those things were given. And you can again click on analyze now. So now in this analysis, the uh, design is actually done. Okay. So go to the post processing mode. Have beam design, and you can in the result you can see the bending moment reflections are all available here. The beam stresses all are available. On B value you have the beam result mode reactions. Yeah, so on for the steel design, we don't have to design for the rebars angle, right? We have to just check whether we have given the right section which will take the loads, so that we can, after analyzing, give the run analysis. Go to the output file, done. You can see the left behind. You can see the steel design and steel takeoff. If you click on steel design, this is the value for that. You can see that the member is passed. That is, the member is okay for taking the loads and self weight. And still take off, you can see the corresponding weight of the beam, which is required for calculation and for estimation purposes. So these are all required for the steel design purposes. So that comes to the end of the tutorial. Thank you.